Hey guys, we'll be starting with the next question of today, and it's called the maximum product of the Subarray, and it's a Leetcode question, and you can check it out the question before viewing the solution. So let's start. Now, the basic approach is that let's talk about what we know about the problem. We know that there is an array, and there can be a positive as well as a negative elements in the array, right? So, before going ahead to the solution, I want to tell you how to solve any problem. Okay, if you encounter any problem, what you have to do is that break down the problem, and if you can actually break down the problem and conquer the small parts, you can actually solve the problem. So it's basically called divide and conquer. Okay, and it's actually a very effective method to come up with the solution. And still, if you cannot divide and conquer, try attempting a very simple version of that problem, right? So in this part, I'm going to talk about the Dane algorithm. So if you already know about the algorithm, you can skip over to the next part and to the solution. If you do not know, let's start. So in the Cadena algorithm, it is basically used to find the maximum sum of the subarray, right? So for example, I have an array here, array 2, 3, minus 1, 2, and minus 10, minus 2, right? And in this array, you have been told to find the maximum sum. So basically, we all know that there can be a brute force approach. You can create all the sub-arrays, and using the sub-arrays, you can calculate the maximum sum, right? This is actually a pretty much naive approach, and we'll not talk about that here. But what does a cutting algorithm does is that it solves the problem in time complexity of O(n), right? It's much faster than the um, O(n) square. Okay, I'm talking about the time complexity here. Okay, it takes O(n) square takes much more time than O(n). Let's start. So how does it work, right? So the contained algorithm contains. I'm just going to talk about the algorithm here. So the basic step is to iterate over the array. We have an for loop with I initialized to 0 and condition of I less than the size of the array, right? And we have an increment pointer, right? So that's what's inside that matters. Yeah. So we'll be talking about what the algorithm does. So suppose that we have two, right? So what it does is that it keeps on adding the number. So let's suppose we have a local max and global max, okay? And we have the first number as 2, okay? We store the 2 here and we update the global max, okay? The global max is responsible to store the maximum value, just like when you're iterating over the array to find the maximum element, right? So if you iterate over the array to find the maximum element, you never change the maximum. And similarly, global max function the same way. And local max can be said to be just like your it is the element. Okay. If I'm still not getting it, let me understand. Let me understand. Okay. What you do to find the maximum of the array? What you do basically is that you check each and every element, and that if it is max is less than nums dot I, we change the max, change max, or basically update it. We update the max to nums dot I, nums I, right? So that is a basic intuition to find the maximum. So Kitten algorithm is almost like the same. Okay, we maintain a local max and we maintain a global max. Now you're pretty much clear about the global max, right? So we do not need to worry about it. It just takes care of one thing. So very beautiful thing about the Kitten algorithm is that let's suppose that we have the maximum subarray till here is 5. Now you might be thinking that when we add minus 1, the answer will decrement. So we do not need to store this, right? Yes, we do not need to store it. Hence, this value will be contained only in the local max, not in the global max. Global max will still contain the value 5. But what is the thing about this algorithm? Is that when you move ahead, there is a possibility that you can achieve a better number, or you can basically say that whatever sum we have found till n element, there can be a negative number. Okay, but after that negative number, there can also be a positive number. Let's say plus 4. So if you move ahead, there is a possibility you can go gain plus 3, right? So this is the basic intuition of the algorithm. If it checks it goes ahead, right? It goes ahead and changes the local max and sees if it is actually greater than the current global max, and update the value. Okay, so we are functioning here the same way. What we do here is that we add the number to the local max. So we have 3 here, 3 is actually added to 2, and we have to select the maximum. Local max will always store the maximum of the current element, that is 3, or the local max, right? What is the local max here? Local max plus the number. So what is the local max up till here? 2 and plus 3. So we'll update it to be 5. So this value 5 here will go here, and it will always check compare with the current element. Now why we are doing this? Now there might be a case, let's suppose that we have encountered a subarray called 10, but we have encountered a value 11. So why we need to take care of this? We can simply discard it because we have much better option that we can only select this 11. Okay, I'm really sorry about this. Not about this. We can actually add this 11 and make it 21. Actually, it's not suited for this example. I will just get back with another example. Let's continue with here. So we have 5 going to here. Okay. Now 5, we have the next element as minus 1. Minus 1, and 5 minus 1 is 4. Okay. So what we do is that we select the maximum year, and the maximum year is 4. Hence we store 4 here. Similarly here, 4 goes on to the next value and we add it to the next I pointer. I pointer is at 2. We add 4 plus 2 6, and we know that the globe also we have to update the global variable, right? The global max here. So here initially global max was 2, but we encountered a greater element called 5, and we need to update the global max here. So 5 definitely 5 is greater than 2, we need to update it and make it 5. But here we encounter a smaller element called 4, so we don't need to update the global element. So that is the basic intuition algorithm. But again, we have encountered a greater element called 6, and we need to update the 6 element here. Similarly, when we go ahead, we will get the values. So local max here is basically, you can say, the minimum of the current element. The is the maximum. Sorry, is the maximum of the current element, and num psi plus local max. Okay, so that's how local max function. Okay, right, it is used to calculate this way. So what can happen here is that you can encounter any other element of here, like suppose there is a 5 and there is 4, so it will select the maximum value of 5, right? It will just move ahead with the 5 value and check the possibility with that 5 if you can move ahead. So that's it about the Kadeen algorithm. Okay, you just need to remember that there is a local max which shows the maximum of the current element, when the current element added to the local max. If the local max is greater than global max, we just need to update the global max and move ahead and return this global max as the answer. Okay, now let's talk about the solution here. So if we can basically understand this, what is the difference between implementing the Kadeen algorithm here? Okay, now let me tell you one thing. Suppose we have two elements, A1 and A2. A1 is a positive element and A2 is a negative element. So when we add these two elements, we can either get a positive value or we can get a negative value, right? But when we multiply this two number, we are always assured that we are going to get a negative value. Similarly, suppose we have a negative value here and we multiply with another negative value here. So we are always assured that k here will always be positive. Okay, but that's not the case of addition. So we have to modify our Kadeen algorithm here. So we have to modify only for the negative case, right? And I say just that we'll do something. If the current element is negative, we just have to do something. Okay, here we have the num psi, right? Now what we have to do here is that we'll just function this same way as a Kadeen algorithm. There is a global max here, answer, and its job is to take the maximum from Imax or the answer, just like the global maximum here. Okay, the global maximum was responsible for the it can either store the local max value or the global max value, and similarly we have answer which can store the answer value or the Imax value, right? Let's move ahead and talk about the Imax here. So I maximum is storing the maximum value till here, and I minimum is storing the minimum value till here. So what is the basic logic behind this algorithm? Let's suppose that we have 2 3, right? And when you multiply these two numbers, you get 6. Similarly, the minimum till here is actually minimum till here, when you calculate this, will be some value, right? It will be basically called 2. But what happens when you multiply a negative number? How the negative? Because if you're not getting this, see, IMAX is what? I'm going to talk about a small example here. If you're just confused, IMAX is like for example I is a 2, so IMAX here is 2, and I min here is 2. But we encounter when your I is at 3. Okay, here R is 3. I'm going to discuss about the next value we'll put here. So IMAX is to either 2 into 3, or it can store the 3 value. But obviously we want to store the maximum, and it will store 6. Similarly, I min, it has two options, either to store 2 into 3 or 3. Hence, it will store the minimum value. But there is a big thing about this minimum value. Like they say, हर शेर का एक दिन आता है. Okay, what I propose to say is that suppose there is a negative number and suppose there is a positive number. Suppose Imax is storing a positive number, Imin is storing a negative number, and a num psi value here is some negative value. Now, what is the thing? Now, suppose that our answer is storing the Imax value because we are already interested in finding the maximum value. But as we say, if we multiply I min till here, there is a possibility that we can actually obtain a value which is greater than I max, right? Because negative into negative, it just gives a positive value. And that positive value, I max can be greater, I max can be less than, sorry, I max can be less than I min num psi into AI, right? I'm sorry, num psi. So there is a possibility of this. Hence, every minimum number, we can say that we can conclude every minimum number multiplied by a negative number will give us a better value, what I propose to say. And every maximum value multiplied by negative value will always actually, it will always give you a worst answer, because suppose we have a greatest maximum value and suddenly there's a small minus one in the path, and you multiply it and you get minus 1000. But suppose our minimum is like, yeah, it is going very depressed, and suddenly it count as a minus one. This is a life-changing experience for this guy. Actually, make it two. So this is a life-changing experience for this guy, and IMIN value will be updated. So what we need to take care is that we do not have to interfere with this IMIN value. But what we can do is that we can swap. If we encounter a negative element, what we do is basically a swap of IMAX and IMIN, right? We swap these numbers because if we multiply a negative number with a positive number, the maximum value will get a much worse answer, and it will become the minimum value. And if we multiply a minimum value with the negative element, we'll get a much better answer than Imax. So that is it. So again, I just repeat it. In this algorithm, what we need to do is that Cardini algorithm only takes care of the positive numbers, but we have to add some special cases for a negative number, because as I explained here, every negative number multiplied negative number can give a positive value, and Cardini algorithm does not take care of this, because when we add two elements, we can get a positive value or we can get a negative value. But here, what we do is that we function the same way as the Cardini algorithm. We maintain a max value and we maintain a min value, and answer will always be something like this, just like in Cadena algorithm. So here you hope you get the intention of what why I'm writing this till here, because if I have written just this value, I would have missed the maximum I can obtain from the minimum value. Just as I said here, that we can obtain a maximum from my thousand this. Similarly, this algorithm functions the same way. The minimum value can get the opportunity to be the maximum if it gets a negative value, but the maximum value will lose it. If it's a maximum value, then it will continue being maximum value. That's not an issue, right? I hope you are able to get the answer. And if you want the code, it's actually available on the lead code, and it's the first code itself. So what they have done here is that they have initialized a loop. They have swapped the elements. We have take the maximum value till here and the minimum value till here, and finally we return the maximum value till here. So that's it, guys. I hope you like the explanation up here. Sorry if it's messed up in between, but this is my second try. I hope I will get better with time. Thank you.